Hi everyone, welcome back to 30 Days of Python. This is day 6 of the Python challenge. Today is tuples. We explore the data structure that often is misunderstood, but it's incredibly powerful. So in the last episode, day 5, we looked at lists. So in Python, lists were very versatile, which then makes tuples very a rock solid foundation in a way within Python. So they look similar to lists, but they have one superpower that makes them essentially a certain solution. They are very much unchangeable, so you can't change a list, you can't change anything to do sorry, not a list, a tuple, apologies. You can't change a tuple by any means. So without further ado, let's get into this. So what are tuples exactly? At a first glance, it looks like a list. It's an ordered collection of items, right? So you'd think that there has to be some crucial difference, and that is the fact that they are immutable or unchangeable, meaning once you create an item or create a tuple and put items in them, you cannot change it. Once it's created, it's done. So in this piece of code, you will see that you can create an empty tuple with the open brackets, the round brackets or round braces. You can create a single tuple with a single comma at the end of it. If you take note of that comma, that's how you end the single item tuple. That would entail that it's immutable and that the tuple contains one item, so you can't change it after this. Remember that a tuple cannot be changed. You can also create a tuple without the parentheses, as you see below the last two lines of code. So with the last line of code, you can see that you don't need the parentheses. This is called tuple packing. Now, why does immutability matter? There are three big reasons. Data integrity, which in this case, when you pass a tuple to a function, you can be sure it won't be modified accidentally. So you can think of this as secure data. Hashability, in this case, tuples can be used as a dictionary keys. Lists obviously cannot. Performance, tuples are generally faster than lists for iterations. Since it can't be changed, you can utilize a tuple to iterate through more conveniently. So when do you use a tuple over a list? This is kind of like a normal Python question that every developer will question themselves on. What type of collection are we creating in the first place? Are we using a list or are we using a tuple in terms of data analysis and data storage? If you look at this piece of example of code, we use lists for collections you need to modify. So things that, let's say it's client, username and passwords. So that's a database that you will update regularly if you need to remove something or you need to add other people to a database for signing into something. Where tuple comes in, it's a collection that shouldn't be changed, right? So in this example, they use coordinates. These are things that shouldn't be changed. So if you have a secure network, you have an IP, this IP should not change in any certain way or form. You can create, or let's say you have multiple IP addresses, and these multiple IP addresses cannot be changed. If it changes, certain things go wrong. So in this case, if you're listing IP addresses, you put it into a tuple. A basic example of this is the days of the week, obviously. So when do you use a list over a tuple? We know that your collection needs to grow or shrink. You need to modify it, add and remove items, and you want to build a dynamic data structure. A tuple comes in when your collection represents something fixed, like days of the week. I said IP addresses that you might need to have a stock standard of, coordinates, or to be more secure, you need a set of passwords, for example. You using it as a dictionary key, you returning multiple values from a function, or you want to ensure data doesn't change accidentally. So going on familiar ideas, like we said with actually what we've shown before with slicing, and within list, we know that you can utilize the indexing and slicing of the list to bring about the different values within the list. So the thing is, you can actually do everything you learned about accessing a list and slicing a list within the tuples as well. So with this example, you can see that not much has changed. The functions that you will be using for indexing, it's the same as a list. The slicing is the same as a list. The tuple unpacking, you can, within this line of code where it says tuple unpacking, you can see you listing out red, green, blue, and yellow, and purple, and assigning it to colors. It's the same as the very first initialization of the tuple, and you can call it, and the output should be red and blue as specified in the example. So when it comes to partial unpacking, you use the asterisks, and we've seen this actually in the in list as well in day 5, where you'd call all the middle parts, and you can specify the first and the last, and everything within the middle can be called. So tuple unpacking is obviously one of Python's most elegant features. It lets you assign multiple variables at once, and then the star operator or asterisk operator lets you capture the rest of the items. So in the real world practical applications, this is kind of where tuples actually come in good hand. So obviously in this example, you'll see that these aren't just academic exercises, they patterns you'll use every day within your programming. So let's look at this example. The first one is returning multiple values from a function, and it's defined with get user info. So you have the name, the age, the is active in terms of if they are working in a certain place, if they're registered. So that's a boolean. So you mark it as true, assign it as true, and then you want to return all the variables that you've listed. And then once this returned tuple, right, you then would assign it to get user info. So username, user age, active status, that's where you assign it. You assigning it to the user info, and you print it out after that. The second example is using a dictionary keys, which obviously lists can't do. So in this case, if you have a dictionary of locations, you can specify a tuple and then assign it. So let's take the coordinates for New York. These are set values that you can't change, because New York won't change its location unless they name it another place, New York, right? As you can see, you can list it in a dictionary, and that will be called upon in a dictionary. And if you call upon the list of coordinates, what it should display is New York or Los Angeles, depending on the list of coordinates, given the category that you can call from a dictionary. The last part is a string formatting with tuples. I feel like this is pretty much a similar way in how we showed upon the old school method of formatting strings. You can actually do it the exact same way. So the third example is string formatting. Here you'll utilize the old school method of formatting strings. As you can see, it says modular S for the string and modular D for the age, which will reference a integer. So as you can see, it reads very straightforward with regards to Python. Tuples reads straightforward as much as lists do. When a function returns multiple values, it's actually returning a tuple, and when you unpack it, you can get clean readable code. So let's go over some methodologies and operations within tuples. Since tuples are unchangeable, they have fewer methods than lists, but the ones they have are very useful. Look at this example. For counting occurrences, for green, in this example of colors, you'll get the output of 2. If you want to find the index, you can use the .index and specify the color that you're looking for, and it will come up specifying which index it is. It says 2, but as you know that indexing reads from 0 first, then 1, then 2, then 3, then 4, and counting onwards. For checking membership, in other words, it will return a boolean, but is it true that an item exists within this tuple or within this list? And it will return a boolean based on whether or not it's true or false. As you can see, it's looking for a membership of purple inside the tuple colors, and that is false. So some operations that we'll go through, we've done concatenations before where you add 2 lists together. The same principle applies here. For repetition, again, like list, you use the asterisk operator to count the list multiple times, in this case a tuple multiple times. For length, the minimum and the maximum, you can again count, you can look at len as in the length of the list or tuple, finding the minimum using min and finding the maximum using max. Even though you can't modify a tuple directly, you can always create new tuples by combining existing ones, like we showed in this example. So here are some obvious mistakes that we all make at times, and like before in the previous days of coding, I've shown you that there are some errors that we all make, and here are some few errors that we all shouldn't be making, but we do make at times. So the first one is forgetting the comma for a single item. It's very common. If the item is single for a tuple, it won't return a tuple, it will return a string, a class of a string. The next one is trying to modify a tuple. You can't modify a tuple, obviously. The final one is confusing changeable elements inside a tuple. So in this example, mixed tuple has 1, 2, and inside block brackets you can see 3, 4. In this case, the output would be exactly that of 1, 2, 3, and in brackets 3, 4. And you can see here you are outputting, you can change, mixed tuple with specifying the index dot append and specifying the number or value that you want to add to a list inside the tuple itself. So obviously keep in mind that tuples are unchangeable, but if it contains changeable objects like a list inside it, those can still be modified. So you can think of it as, if you were to use it in real code, for this example with list, you can see it as like a big database. Things that shouldn't be changed, or let's say a location shouldn't be changed, but something that can change is maybe the dates inside that. So you can specify something like the locations that you should meet at, but the dates should change in this list, in this tuple. So some tips for practical exercises. You got a family members exercise, perfect for tuple unpacking practice, creating fruits and vegetable tuples, great for understanding unchangeability within a tuple. You can join a tuple and tuple methods to get comfortable with count and indexing. So remember, a key factor is that if you need to modify a tuple, you need to create a new one. I hope today's lesson was helpful for you, and I hope that the progress within the 30-day Python challenge is going well. I will see you tomorrow. Thank you and goodbye.